Using the quadratic formula. The quadratic formula is used to find the zeros or the roots of the quadratic equation if it cannot be solved by other means such as graphing, factoring, or completing the square. Remember that the zero or the roots are where it touches the x-axis. So it's going to be where it touches or crosses the x-axis of your graph. So our standard quadratic equation is written as ax squared plus bx plus c, where a, b, and c are numerical values. The quadratic formula is x squared is equal to negative b plus or minus the square root of b squared minus 4 times a times c. This minus 4ac is all one term, and then that whole numerator is going to be divided by 2a. So if we look at example 1, the first thing you need to do is just plug in your information that you know into your quadratic formula. So my negative, so I have a negative b is negative 5. So yes, you're going to have double negative signs here. Plus or minus the square root of b squared, so negative 5 squared, minus 4 times my a. If there's not a number in front, it's understood to be a 1. So a is 1, and my c is a negative 24. So that's all underneath my radical sign, or the square root. And then I'm going to divide the whole thing by 2a, which is 2 times 1. So when I start by solving this whole radical, remember your orders of operation. You don't have to show every individual step for orders of operation, but make sure that you're doing like the multiplication before the adding and the subtracting. Don't just work left to right. So if I have double negatives, we know that these two negatives are going to change to a positive. So now I have a positive 5 plus or minus the square root. So I can do multiple things under this radical at the same time. If I square this negative 5 times negative 5 is going to give me a positive 25, minus, I'm going to do 4 times a negative 24. Because here's my negative 4, 1 times negative 24 is negative 24. And again, this is all over the value of 2. For my next step, you're going to keep working to solve it the whole way through. So nothing changes with my 5. I still have plus or minus. Underneath my radical now, I have 25 plus 96. This is all going to be divided by 2, because when you do negative 24 times negative 4, you get a positive 96. If I continue further, I have 5 plus or minus the square root. 25 plus 96 is going to give me 121 all over 2. And now we're going to start solving with my square root. So I'm going to have 5 plus or minus the square root of 121. 121 is a perfect square because that would be 11 times 11. So it'll be plus or minus 11 all over 2. Once you get to this point, when you've simplified and done everything that you can up until here, I'm going to now write it as 2 separate equations. I'm going to have 5 plus 11 divided by 2, and I'm going to have 5 minus 11 divided by 2. So when I go to solve these individually, 5 plus 11 is going to give me 16 divided by 2, which will give me 8. And 5 minus 11 is going to give me a negative 6 divided by 2, which will give me negative 3. So your answers for this are going to be x is negative 3 and positive 8. So continuing on, I have two more examples that I want to work out. The first one, so again, you're just plugging it in to your quadratic formula that I've rewritten up here. So I have a negative b, so since my b is a positive starting off, I'm just going to have a negative 6 plus or minus the square root of b squared minus 4 times a, which is 5, times c, which is 1, all over 2a, so 2 times 5. So now it's just solving it step by step. So again, I have negative 6 plus or minus underneath my radical. 6 squared is the same as 36. If I have negative 4 times 5, that's going to give me negative 20 times 1 will still give me a negative 20. And then it's going to all be divided by 10. If I continue, I have negative 6 plus or minus the square root. 36 minus 20 is going to give me 16 all over 10. So then I have negative 6 plus or minus, again, 16 is a perfect square because it's 4 times 4. So it'll be square root negative 6 plus or minus 4 all over 10. Once I get to this point, again, now you're going to rewrite it using two equations to solve. So my first equation is going to be negative 6 plus 4 over 10, and my second equation is going to be negative 6 minus 4 all over 10. So as I solve these through, negative 6 and positive 4 is going to give me a negative 2 over 10, which will give me a negative 1/5. And when I solve this one, negative 6 and negative 4 is going to give me negative 10 over 10, which means it's going to give me a negative 1. So for this problem, x is going to equal negative 1/5, comma, negative 1, or and. So it's going to touch your x-axis at negative 1/5, and it's going to touch it at negative 1. And the last example for these problems. Example 3. If I have x squared plus 6x is equal to 14, the first thing that you need to do is move the 14 to the left side. So you're really going to start off with x squared plus 6x minus 14 is going to equal 0, because you want to set the whole thing equal to 0. Once you set it equal to 0, then you can use your quadratic formula, which again is x equals negative b plus or minus square root b squared minus 4ac all over 2a. So when I plug in my information from the second equation that I've rewritten, I have a negative 6 plus or minus the square root of 6 squared minus 4 times a is 1 and c is now a negative 14 all over 2 times 1. So now it's just going to be solving it all the way through. So I have negative 6 plus or minus the square root. 6 squared is 36 minus, or actually plus rather, because a negative 4 and a negative 14 is going to give me a positive 56, and this is all going to be over the whole number 2. The next step, negative 6 plus or minus the square root. When I add them together, I get a 92 all over a positive 2. Since 92 is not a perfect square, we need to do its prime factorization. So off to the side here, I'm going to do 92. I know that 92 is divisible by 2 because it's an even number. So when I divide them both by 2, I'm going to end up with 46. Since 46 is still even, I can divide it again by 2, which is going to give me 23. And since 23 is prime, I can't go any further. So my factors are going to be 2 times 2 times 23. So when I rewrite this radical, a single 2 comes out because that would be square rooting 4. So when I rewrite this, I'm going to have, minus 6 plus or minus a 2, because I was able to factor that out, all over 23 divided by 2. I can't simplify this any further, so now I need to rewrite it as 2 separate expressions. So my first one is negative 6 plus 2 radical 23 all over 2, and my second one is negative 6 minus 2 over 23 all over 2. So you can keep your answers like this, or if I think of it as splitting up fractions, negative 6 can be divided by 2, so I would have negative 3 plus radical 23, or I would have negative 3 minus radical 23. So both of these could be your answers, but you would need both of these because you need the plus and the minus, or both of these because, again, you need the plus and the minus.